there's a big difference, in my opinion, of whether you can print a part versus whether you can manufacture a part and inspect the part. And that's the value proposition of the CoE in this consortium.
Welcome to another episode of Inside IALR. Thanks for being here today, and thanks for joining us for our first episode that we have recorded virtually. This is much different than we normally do. Normally we're all in person and together. Now we are staring at each other on our computer screens. So we have three guests with us. We have Ereina Avery, who's the program manager for the Additive Manufacturing Center of Excellence with Austal USA. We have Jon Harrison, who's the president of Global Additive for Phillips Corporation. And we have Jason Wells, the executive vice president for manufacturing advancement here at IALR. So thank you guys for being here.
Thank you.
Thanks for having us.
So we're here to talk about the AM CoE, the Additive Manufacturing Center of Excellence. I think some of our audience has probably heard about this. So we'll kind of do a brief overview at the beginning, but really want to get into some of the the primary technologies that we've been using, the primary lessons that have been learned by this very unique public-private consortium over the past few years. So I'll just kind of open it up to start. Whoever wants to give the 1-minute rundown of what is the AM CoE, what is its mission, and who is involved?
So I'll take that one. The AM CoE was a program that started a couple years ago, foundationally because of the work that IALR is doing with the ATDM program. We were able to get a building over there, the Center for Manufacturing Advancement. We have various partners, a consortium model inside the walls. And the idea was that we would convert parts that traditionally are causing supply chain issues for castings and be able to make them additively. So we have a partnership with Phillips, who is doing all of the design and additive manufacturing in the Bay. And we have the Institute providing all of their metrology and machining experience. We have the Industrial Inspection Analysis, we call them IIA. They're doing all of the destructive testing, NDT, and other types of Navy testing within the walls, and then some other partners in the group in order to make parts in additive.
Awesome. Jon or Jason, anything to tack onto that?
I think Ereina really nailed it. We do have a vision and mission statement for the CoE, and Ereina described it, but we want to be the go-to and the thought leader and the technical resource for the Navy as they operationalize advanced and additive manufacturing. And I think bringing together this unique consortium helps us do that, because every component of the CoE is important, from printing the part to figuring out how to machine the part, how to make sure the part's good through NDT. All those components lead to a quicker supply chain that can address some of the issues that the Navy's having in their critical castings part. But it also projects into serial production. And the goal is to come through these technical challenges quickly for the first time so that they can scale for serial production later.
I guess I would just add, Caleb, that what's really unique value proposition with this particular consortium is the fact that we have end-to-end capabilities within the program. So we're able to actually go from a traditionally 2D drawing, traditional part concept, and then mature that all the way through to a finished product and hit all the steps and stages between. So it really allows us to mature the technology through the entire ecosystem that a part would have to travel through in order to go from concept to actually being put into production or put into action. So that's what really, truly, I think makes this consortium unique. And then also each partner within that consortium has that ability to really lean in hard on their area of expertise and really bring that to the table in a shared format. So there's an overarching goal also of creating this one factory flow from a 2D drawing to a dynamic part that's able to be put into service at the end of this.
That's really cool, and really cool to see. I mean, exactly what you're saying. One, that it's all of these different organizations and companies working together, and to that end-to-end capability of, this isn't just it's not just figuring out the 3D printing part of it. It's figuring out the whole process from end to end, which obviously is what, the companies who are going to be making these parts would need. So can you all talk about kind of and this is a very broad question, so take this at whatever direction you would like, but kind of the evolution of additive manufacturing and how we got here to the point that the U.S. Navy is trying to implement this technology as much as it can within its own fleet production and sustainment.
Yeah, it's an interesting challenge. I'll take a crack at it. Additive manufacturing has showed a lot of promise in a bunch of industries. And initially it was prototype work, and then it started getting embraced by these OEMs that were trying to make parts better or more lightweight. So design challenges that go along with traditional manufacturing can be alleviated through additive manufacturing. But then it's applied to this challenge where you have casting issues, especially in low run, high value castings. Additive manufacturing can offer speed to execution. So a traditional casting for a component might take 50 weeks to get, and you might need to order 200 of them. And that's great for like engine manufacturing when you have a constant production line. But let's say you needed 1 or you needed 10. Additive manufacturing can short fuse the production of that near net part to get it into the production line a lot quicker. And it makes a lot more sense in these high value parts when you're having, for example, a submarine waiting on one particular component, and you can make it a lot quicker.
I would just echo what Jon was saying in the sense that, this opens up additional opportunity. There's always that dynamic in any kind of market, as he was talking about, between short run needs or special tailored situations that are time constrained and need a really expedited type of lead time. So additive brings a whole nother dimension in being able to be responsive to the broader market needs, and that's a real opportunity for the Navy to mobilize when necessary, when needed.
Can you guys kind of break down the main, I guess, the primary 3 types of additive manufacturing we're talking about? I mean, 3D printing is obviously kind of the broader word, but there's lots of different ways to do that. So kind of explain powder bed, wire arc, and friction stir. I know, it's correct that we're working with all of those, right?
Yeah, I think primarily we're working with the most mature technologies out there. And Navy right now is focused on powder bed fusion and direct energy deposition. And powder bed fusion basically takes powder and scrapes it over a build plate and then burns a certain shape into it, and then scrapes some more powder, so it produces a part layer by layer. And allows for very complex parts to be made with internal channels. And quite frankly, is the one technology, when you look at metal part production through additive, it's the most adopted technology because it's been embraced by the aerospace and space industry. Direct energy deposition is sort of like welding. So you have a welding head that's uniquely positioned around a part to add material rather than just weld 2 pieces together. So you basically are welding layer by layer into a unique shape. And the Navy's primary focus right now is on wire arc direct energy deposition. Navy has a ton of experience with welding, so they're leveraging that technology to produce parts. Now, they're 2 different technologies, and they both have pluses and minuses, if you will. I think powder bed fusion is really good at intricate parts, and it's probably the most mature technology out there that's been used for many, many years. Direct energy deposition allows you to make bigger parts, maybe with less complexity, but very large parts, 1,000-pound parts, very large valve bodies or near net shapes, if you will. But, both of them offer and present challenges which in the CoE we are addressing with this unique consortium. So machining a powder bed part is a lot different than machining a direct energy deposition part. and requires special considerations for tooling, feeds and speeds. And that's where IALR comes in with some unique solutions on how to machine each one of them that we can pass along the industry for scale. They also require some different NDT inspection approaches that our other partners, IIA, are addressing and looking at, so we can make sure that the parts we're producing are good, because a lot of the times these parts go into critical areas. And, I guess when you look at the entire consortium, Austal is bringing all these unique things together and managing and making sure that, the parts printed on time, and we're connecting with the machining person and the team over there to make sure that they understand what they have to do, and coordinating shipments to heat treat. All this stuff has to be put together, and Austal has the responsibility of herding the cats, if you will, to make sure that at the end of the day, we're beating the traditional supply chain.
No, I appreciate that explanation of those different methods, and kind of, that breakdown that, DED is more sort of like welding and better for the larger parts, and the powder bed fusion, better for those more intricate parts. Can you all kind of talk about the process of deciding what parts get sent to the AM CoE for you all to develop these 3D, basically these recipes for how to 3D print these parts? What is that process like? How is the Navy selecting what parts you all receive?
Yeah, so I'm primarily the person who has that responsibility. We are funded by the DERPA MIB, and they work with all the different shipyards that need repair, with Electric Boat, with the Newport News, all the people who need parts. And we are getting flooded with requests to support. And so the projects are very wide. A lot of them, the emergent needs are for, like Jon said, a submarine that is coming in and is going to start install in April. And they send us the drawings and they say, hey, this material is the same as something you might have at the AM CoE. Can you make that part an additive? And so the Phillips team and the Institute team and our IA team will all gather together, including Austal as well, and we will look at that part and see if it is something that is doable. And a lot of times it is, especially if it's a casting replacement. And going back to what you were saying about castings, there's only so many foundries that are in our disposal. And so that's kind of like the value of additive. And we also have some networks of suppliers that might not have exactly what we have. They have something supplemental. So we have an evaluation process where we gather all the consortium partners together. We look at the design and we'll see if we have that capability. And a lot of times we do. There are some newer parts that are coming because we have been able to solve a lot of challenges and get installed parts. We're starting to get into how to partner with valve manufacturers who can assemble and do that further testing to get it on the ships. But that is primarily how it goes. We've got a website, navydigitalc.com. There's a support request form, and you can anybody in the Navy can fill in a request, send us the files, and we will take a look and evaluate.
This is the coolest part of it, and this is why the consortium is so cool. I've only been a part of a few of these, in Ereina, you're a part of many more than I am. But these experts that are on the line get in the room of this consortium, and someone puts a part and says, hey, we need a part by this date. Can we make it? And the print guys will get in there, and the guys and the girls will start looking and say, all right, we could print it on a powder bed fusion. And, we orient it this way. And the IALR team will go, hey, but if we do that, I'm not sure if I can machine this feature. Can you add 30 thousandths of material on the left side of it so I have something to clamp on? And the designers will be like, yeah, we can put more material here. And then the NDT guys will go like, all right, well, how am I going to inspect this? Am I going to be able to see in this? All these experts come together to solve this problem and bring their own expertise and collectively find the right solution so it's manufacturable. There's a big difference, in my opinion, of whether you can print a part versus whether you can manufacture a part and inspect a part. And that's the value proposition of the CoE in this consortium.
That's a great point that Jon makes. We're That's why that's so unique what we do here of taking the whole ecosystem into consideration, because I think one of the challenges you would have is, sure, you can go out and you can buy 3D technology and you can figure out how to print something, but then what do you do with it? And how do you get it to that final destination? And, that having this collective here really helps us define that. And again, as was mentioned by both Ereina and Jon, that's all part of really being a force multiplier to the supply chain, trying to help them mobilize and push out, and, taking all those lessons learned and combining them to the advantage of making parts quickly and getting past all that initial engineering and first article bumps and bruises.
Jason, you just mentioned the supply chain. So I know the original mission of the AM CoE was very much to make recipes or the technical data packages to then be able to pass off to the supply chain, so that these companies would have these recipes and could reference those and how to create these parts with additive manufacturing. With that being sort of the baseline, that, there might be tweaks they could make and things like that, but that would be the baseline. This works. I know. And we had the guys from the Maritime Industrial Base on the podcast several months ago, and they told those stories of pretty quickly transition to not just making recipes, but, we need this part, and as soon as you are able to print it for us. So talk about kind of those dual missions of, yes, you all are making the recipes for other companies to then be able to manufacture those parts when they're needed, but also basically getting the deadline of, hey, we need this part as soon as you are possibly able to get it so that the ship can go back in the water.
I don't know that they're separate missions. I just feel like it's an evolved mission. So originally we were doing these technical data packages for new construction, which has lead time. And so that immediate need isn't there, but we knew we would need to make at least one part and prove that we could make it end to end and do the testing. But then there were these needs at the waterfront that they need a part right now. And so our TDPs have evolved to a place where we actually have proven that the part can actually make it to the boat. And we have all this additional feedback from the Navy saying, hey, we're going to need you guys to do welding verification. We're going to need you guys to provide qualification documentation. You need to mark them a certain way. They need to be surface finished a certain way. They need to be hydro tested a certain way. And so it's grown into probably what we originally thought was like a simple thing. And that is the supply chain challenge. It is not easy to get a part onto the boat without understanding the full requirements. And like both have said, like that's the value proposition is we are getting all of that stuff together. So you're getting a more complete, what they call a ready for install part out there instead of just an AM preform.
Stay with us. We'll be right back.
When you need reliable results, IALR delivers. Our Applied Research Division works with businesses and universities on everything from product testing to process improvement. Our expertise spans chemistry, biology, plant growth, advanced materials, and more. We've got the experts, the labs, and the tools to get you results you can use. See how at ialr.org/research.
I'll tell a story, and I'll try to make it transferable to something you might see in your own house rather than get into specifics of a military part. But this one ship was having a problem with one of their garage door openers, and they couldn't get their vehicles out of it. So they looked in their supply chain, and the only way to get the part that was broken was to buy the whole garage door opener frame and springs and all that. But all they needed was this little bracket that held the sensor that made sure that the garage door opener was open or closed. And this boat needed to go out in 30 days. So the CoE stepped in and was able to reverse engineer and design a new bracket for this sensor, print it, machine it, inspect it, and ship it within 19 days. And it's something that the Vice Chief of Naval Operations carries around this bracket as an example of how fast the CoE can move to respond to these sustainment style parts. Now, if that same bracket was requested today, they actually have used our technical data package to create an NSN number in their supply chain. The procurement system can order just that specific bracket now, and the COE can produce it in 5 days. We did the first one in 19 days, which we thought was quick, but now, because we went through all that engineering and figured out how to print it and provided that recipe to someone, you can produce it in 5 days or less.
Yeah, no, that's such a cool story of kind of the impact that the COE is having. And obviously that was not the expected impact when you all started this, that there would be those rapid turnaround parts, but clearly that has become a huge part of what you guys do, is making those sustainment parts to keep these ships online, to keep make sure these ships and submarines can get back onto their mission as quickly as possible.
I think we have a bunch of dedicated folks down there had by this mission. And, on that story, that part request came over December 19th. In the U.S., that's right around Christmas time when we're all trying to find time with our families, and the print was done on Christmas Eve. Members of this consortium were at our facility on Christmas Eve working this part, machining this part, shipping this part out to make sure we're on the mission.
As Ereina pointed out, even though this is a different dimension to the original scope of the TDPs, as you mentioned, it's incredibly beneficial to us. We gain a tremendous amount of lessons learned on each time we push out on these requests, and that feeds back into the science that we're gathering and the data that we're gathering. It also really accelerates the whole process of the impact of the COE as well. So I don't think that they're exclusive of each other, because they definitely feed each other, as Ereina pointed out.
And just as a follow-up question to all of this, I mean, how many sustainment parts have we produced that have actually gone on to be put into action in ships and submarines? And then how many of these technical data packages have been created to date? And that's a very specific question. So if we don't know the exact answer, that's fine.
No, I do know the exact answer. So we have 22 installed right now. We've got, they're on destroyers for surface fleet. We've got a couple on Ohio and Virginia class submarines. We actually have one on an aircraft carrier. And then we have a specific project right now with Portsmouth Naval Shipyard where we will have another 10 by the end of the year. And then we also work with surface fleet. So we have a bunch of different parts. And just all of the work that we've been doing over the past few years has gotten to us to a point where we are very good at figuring out how to make a part that is compatible to the original design using its current technical requirements. And so as we do that, we are able to network with suppliers. We will be able to give those TDPs. Everything we do at the COE gets a TDP. And as we get those, the learnings about how to do markings or how to get them onto the boat or anything like that, we have that available to the next person who will be producing those parts.
What is in a TDP? So that, you guys create this technical data package, this essentially the recipe for how to create this part. What exactly is in there? What does that look like for the suppliers who then get that?
There's a bunch of instructions. Some of them are related to how to print the part or best suggestions on how to print the part, because there is some uniqueness in each technology on how to print the part. There's also instructions on some best practices on how to fixture the part or approaches that could be taken to accelerate that. There's specifics about the materials and the testing requirements that go along with that. And it's a very standardized form that is now universal across the supply chain that we're plugging information on to try to reduce the amount of non-recurring engineering that can be done. Because I think if you give it the same challenge to two different people, they can both figure it out. They're going to come up with slightly different approaches, but they're also in that quoting effort, in that bidding effort, they're going to have to put engineering hours into that and charge for those engineering hours. And if we've already done that, then speed to execution and eventually cost goes down.
Yeah, I actually have a good news story on that. We recently gave a couple TDPs to a few suppliers that are in our network. And I didn't get charged any NRE for these, by the way. And so we were able to quickly get quotes. They're on the printers. There's about 8 different suppliers working on parts. And I was very happy to learn that they were using different machines than the ones we have. So a couple of them are using the EOS M300s, which are a little bit smaller, but machine bigger, for laser. We have a couple that are being printed on Nikon SLM 280s with 2 lasers, and then some different DED machines. And it was one of the concerns early in the program that the things that we did in-house would be very machine specific. And we assured them that that would not be the case. And it's proven now that that is absolutely not the case, that the work that we do at the CoE is transferable to the supply base. So I was very encouraged by that. So I just think it just helps the Navy mission to scale additive even more. That we are able to transfer our technical data packages out to industry.
And Jason, can you talk a little bit about, so the Additive Manufacturing Center of Excellence is hosted within the Center for Manufacturing Advancement here at IALR. Jason, can you talk a little bit about just kind of briefly what is the CMA and kind of how that creates the ecosystem where all of this work can happen?
Yeah, certainly. So the original vision of the CMA was to set up a center that would basically focus on optimization efforts. And what I mean by that is take current and relevant existing technologies, become very good practitioners at applying those technologies, and then helping to push those technologies out into industry in order to help expedite the adoption of those technologies, minimize the disruption, in order for our industries to stay competitive and to stay very robust and move out, move forward, and progress. That was the original vision. As Ereina mentioned early on, as we were standing that up and communicating that vision, at the same time in the background, we had engagement with the Navy around the Accelerated Training and Defense Manufacturing Program, the ATDM program, which is our workforce training program. And when they learned about what our vision was for the CMA, it aligned perfectly with their concept or their motive of wanting to bring in new technology in the form of additive manufacturing into their supply chain. So fortunately, we had created a facility that was intended to host or house multiple bays that would allow for different technologies to be brought into the space and then explored. It aligned fairly well, and luckily we had the square footage available that from the very beginning, before the facility was actually able to be occupied and had a CO attached to it, we had already engaged in an agreement with the Navy and the various partners, Austal as the prime, Phillips leading the additive efforts to start to bring technologies into those various bays that we had created in the CMA. And that started the initial concept and structure of the CMA. In the 2.5 years or so that it's been here, started out with a bunch of empty bays, and now I'm happy to report that we are pretty much at full occupancy in this building. So we are definitely filled up and looking for opportunities to expand out further on the campus here. But I can say that we're very honored and grateful to host it here on campus. We also we create some connective tissue between our workforce training program for the Navy, which is the ATDM program, and the CoE. And because they coexist on the same campus next to each other, that's a really unique value proposition for the future workforce that we're training, as well as the future technologies that we're exploring, on the CoE side. So some really good synergies there. And it's been fantastic because it teaches our team also how to collaborate and cooperate and coexist with other organizations within the CoE space. So it's been a fantastic experience thus far.
Stay with us. We'll be right back.
Need a place to bring people together? The IALR Conference Center in Danville has modern and flexible spaces, great food, and a team that takes care of the details. Big or small, we'll make your event run smoothly. Plan your next event at ialr.org/conference.
There were some really smart Navy leaders, whether it was Admiral Papano or Matt Sermon or Whitney Jones, that recognized something unique about Danville and something that we had seen from our partnership with the Danville Community College and the IALR team to locate this AM Center of Excellence adjacent to the Accelerated Training for Defense Manufacturing program. Why I say that is workforce is very critical, and we've had the good fortune of having some interns that were graduates of the ATDM program work within our bays on some of the additive equipment. And what we find, the graduates are motivated graduates. They have good work ethics. They understand how to communicate and how to learn. And we've been fortunate enough to hire a few of them. I know that every partner in the consortium has hired at least one ATDM graduate for the efforts that we're doing down there. And it's a testament to that program and the foresight of the Navy to locate the COE right next to the ATDM program.
No, I appreciate you recognizing that, John. And we definitely appreciate all the partners hiring our students for sure. But it like they say, it takes a village. So, everybody who's a partner in the COE very much has a hand and an influence in our workforce training program and ATDM as well. So again, going back to the earlier statement of everybody bringing a level of expertise to the table, that's also a huge advantage to have those experts to tap into on curriculum and training and different things like that. And we learn things in the COE that really benefit us in then pushing that into curriculum as we're discovering things that we feel are going to be important for these students to succeed when they get out into the workspace.
ATDM is the coolest. And the more that I think about that program, that's my conclusion. I think what you guys are doing in the AM CoE is also the coolest. We'll put those right here.
The CoE is super cool. We just got to be a little more quiet about it.
Sure. So just for the last few minutes before we go, because Jason, you said it's been 2.5 years roughly since. So what have been kind of the biggest lessons learned, challenges faced, those types of things for the CoE during that time, whether that be something technical, whether that be something in learning how to work together as a group of companies? I mean, what have been some of the kind of the biggest lessons learned, takeaways over these last 2.5 years?
I think you identified, Caleb, challenges of 5 companies coming together with different cultures and different approaches. But, my takeaway is that we're all had by this mission to help the Navy support production of submarines and in-service parts and components across the marine industrial base. And whenever there's conflict, we always remember that our real mission is to support that warfighter and provide them the best technology, equipment that's in good working condition, to make sure that they have what they need to complete their mission. And as long as we continue to remember that that's the most important thing we do, the conflicts that we have seem very minor and we work through them.
That's an excellent point, John. I mean, I think, when you have a mission and when you're doing the right things for the right reasons, it's a lot easier to create that, collaborative environment and set aside, any kind of selfish wants and needs, because, the mission is much bigger than any of us. And, that's a real kind of North Star that we can all point towards for sure.
Back to the whole foresight of the Navy in starting this mission 2.5 years ago, they knew that it would not be easy, right? They needed an incubation space with the right partners to start it. And it's a small example of like the global mission of this, right, is supporting the warfighter. And so we test it in this small little environment, and you realize the breadth of it. the amount of people that it takes, right? We didn't even talk about the amount of welding engineers and material scientists that are in the background trying to figure out like whether this is an equivalent technology. They're out there. They are feeding us all this information. They're asking us to make test samples. Of course, we're making parts too, but we're also making a lot of different shapes and coupons and things that have to go through tests, because it's not just the part. Everybody on the waterfront and everybody in new construction, they need to know that this is not going to endanger all of the people who are on board these ships and boats. And so there is a much larger effort in order to make this scale, and it is working. But it is a challenge, and it's not easy for it to have happened with all these small groups working outside of Danville. And so I think that is like the takeaway here, is that all the work that we're doing, it might be on a small scale, but it is going to reach out and support the U.S. Navy.
I think one of the things Ereina just said that's really important is this isn't an R&D effort. This isn't a science project. This isn't, us trying to, chase moonshots or reinvent things. In a traditional R&D environment where you may take years to mature something, we don't really have that luxury. So we're very much flying the plane. We're building the plane as we're flying it, I guess is the best way to put it. But we're operationalizing, the technology immediately and then trying to push it out into industry in real time. So that requires our teams here, which are phenomenally talented and phenomenally dedicated. As Jon pointed out, the whole venture over a Christmas break of getting a part out, but it's just that operationalizing technology on behalf of the Navy and the nation. It really takes a special group of people. So, and then capturing, I'll go back to what I said earlier about having that end-to-end capability. I can't express how important that is because as Jon indicated earlier, you can print something and think, okay, this looks great. It looks like it's supposed to look. And then you go and machine it and it's absolute mission failure. So it's having that whole ecosystem to take into account so that you don't only get partway down the road. We're getting to the whole destination. So again, we can operationalize this technology.
Caleb, I'm reminded of a quote. I think, Jason, you were in this meeting. Ereina, you might have been there as well. Rear Admiral Papano is in with a bunch of the engineers from the Navy, and we're in the room and we're trying to figure out how to come through proving that this additive part is as good as a casting part. And there were some skeptics in the room saying, no, we can't do this. Well, we'd have to do this and it would take this much longer. And you could see Admiral Papano's frustration. And finally, he slams his hand on the desk and says, damn it, don't tell me no, tell me how. And, that quote now hangs in the COE as a reminder that we're there to help find solutions to problems, find ways around roadblocks, and not tell people no, figure out a way to get to how.
That's awesome. What a great mission, to not tell anyone no, to just tell them how. I like that. On that note, I think that is all the questions that I have, but I really appreciate you guys being here today. I think this is such a cool project, I guess it would be the word for it, that you guys are involved in to ensure, as you said, it's all about the warfighter. It's all about making sure that these Navy personnel have adequate ships and submarines that will keep them safe, protect them, and remain in use as long as they should. So just such a cool project that you guys are involved in. But is there anything else that you would want to add or think it's important that people know before we go?
I'd like to add one thing, Caleb, is just to emphasize the talent that's in this building. There's folks like Jared Springer and Phil Burton and Jeremiah Williams, and, the list goes on and on of folks that just, when you combine the actual years of hands-on experience, I'm not talking in labs, but I'm talking working in the trades and in the various disciplines that they're in, it is hundreds of years of experience that are being brought together and applied in this particular effort. And it's just real inspiring to work around people like that, that are bringing a lifetime of experience to the table to try to put behind this mission and help with this mission. So just really want to emphasize that, because it's just a real honor to have my office here in this building and be able to interact with those folks on a regular basis.
Appreciate the opportunity to speak with you, Caleb, and always appreciate the partnership of the group of speakers on this call.
Well, thank you guys for being here. We appreciate it.
Thank
Thank you, Caleb. Appreciate it.
At IALR, we're training people for careers supporting the construction and maintenance of ships and submarines. ATDM, or Accelerated Training in Defense Manufacturing, gets students ready for defense manufacturing careers in just 16 weeks. Skills like machining, welding, additive manufacturing, non-destructive testing, and metrology. The best part? Most graduates land great jobs right away. If you want a fast track to a career with impact, check out atdm.org.